probably all of you would have a difficult time with that if you're paying for your own living expenses. That's what's happening in the cell, and so the cell is going to become injured / die. Did I answer your question? So that's one example. If I asked all of you to go outside and sprint around this building as fast as you could, your muscles would be burning up ATP at an incredibly high rate, much higher than the ability of the mitochondria to supply ATP. And so while some glucose would be broken down and go in that direction, because you're using up glucose at such a high rate, some of it's going to go this way. And then you end up producing a lot of lactic acid, or the ionized form of lactic acid, which is called lactate. That changes the pH of the muscle, changes the ability of the muscle to contract, and now you feel as though you are fatiguing. Okay? All right, so let's continue on with this. So we've got our pyruvate. Which is now going to be shuttled into the mitochondria, because we're going to assume that adequate amount of oxygen are available. So here's the outer membrane of the mitochondria. Here's our inner membrane of the mitochondria. The space between these two membranes, you guys can tell me, is known as the intermembrane space. So here's our molecule of pyruvate. It's shuttled across into the matrix, where it's converted to acetyl coenzyme A. An important part of this story is that as a result of converting pyruvate into acetyl coenzyme A, we end up producing 2 molecules of CO2. More importantly, however, we end up capturing 4 electrons in a high energy state. So we've got 2 NAD plus 4 protons plus 4 electrons. So the NAD captures these 4 electrons,